Hi, my name is Dorit. I'm head of data science group at Light. Thank you, Moran, and thank you, Women on Stage, for hosting this amazing event. I am really excited to present here today how we cracked the cyberbullying model. My name is Dorit Zilberbrand. I am head of data science group at Light. We detect online toxic behaviors. I have a PhD in computer science from Bar-Ilan University. My thesis was on building statistical models to detect suspicious behavior. To give you a little bit of background on myself, I have been working in the tech industry for almost 20 years now, providing algorithmic solutions to real-world problems. Why Light? I have 3 daughters. Noah, my eldest, is 13, Yael, 11, and Shira, my youngest, is 7. They spend most of their time online, and even more so since the start of COVID. They research, learn, communicate, and play interactive games. My youngest Shira knew how to use the WhatsApp recording function before she knew how to read or write. Unfortunately, this online activity comes also with risks. They are exposed to adult content, cyberbullying, and even pedophilic behavior. As a mother, I feel privileged to be able to contribute my knowledge and skills to make the online world safer for all the children, not only my daughters. At Light, we have developed a large number of algorithms, especially for this purpose. We have AI models to detect pedophilic behavior, bullying, shaming, self-harm, hate speech, etc. Developers or companies can integrate our models into their solutions using our APIs. We get inputs in the form of text, images, videos. We send them into our engine and output toxic behavior like bullying, shaming, etc. Today, I would like to focus on one behavior, the cyberbullying in text messages. So let's begin and crack the cyberbullying model. So what is cyberbullying? Before we start designing our algorithms, we must first define it. Cyberbullying is bullying that takes place online. It can take place in chats, forums, social networks, etc. It contains personal insults cause humiliations, hate, threats, and sexual harassment. In this talk, I will give examples from the personal insult model, but it applies to all the other models under the cyberbullying. Why is cyberbullying so challenging for NLP? Let's think about the way people communicate today. When my 11-year-old daughter sends a text message to her friend, she uses slang, acronyms, typos, emojis, and many other nuances. Informal language is difficult to interpret. And we all use it today. So how do you interpret an angry face or a slang like bite me? And then there are more complex examples, like you see on the screen. Understanding such sentences is difficult, also for humans. Another challenge is that the same word can appear either in a personal insult context or in a non-personal insult context. One may think that dictionaries or keyword spotting can solve our problem, but this is not the case. On the slide, you can see examples for words that appear in both contexts. Let's take, for example, the keyword hate. I hate Jane, it's a personal insult. I hate myself, this is not personal insult. Are you retarded? It's a personal insult. She think he is retarded, this is not a personal insult. And there are many more examples. The context is important. And personal insults evolve over the time. A new personal insult that came up is, if 2020 was a person, it would be John. This is a new personal insult, and there are constantly new insults. To collect all these kind of sentences and to build our model, we developed a wash, rinse, repeat data science method that brought us to high-quality models. Let me walk you through this wash, rinse, repeat data science method. So we start by reading scientific article and defining the behavior in question. For example, we define what is a personal insult and which type of sentences belongs to this behavior, as we discussed in the previous slides. Our young team of analysts who specialize in social media collects all relevant examples. Imagine the time and effort it takes them to collect all these kind of sentences, all nuances of informal language. They need to understand each sentence and label it to the correct category, meaning to find out which behavior the sentence belongs to. They collect, annotate, analyze, and redefine the behavior again and again. When there is enough data, our science team collects this data, pre-process, and build a model. Then we do an error analysis. The scientists and the analysts sit together and view the results of the model. This helps us to redefine the behavior and make better models. These iterative loops of data and science, separately and together, help us to define the behavior better and better and provide more accurate results. Since we have been using this method, our models improved dramatically. We have been working on the personal insult model for about a year now. In the graphs you can see the improvement over time. As the training size grows in green and the agreement rate between the analysts grows in orange when the behavior is more and more defined, as a result we see increasing F1 scores. This improvement in F1 scores also reflects the model improvement over time. Now let's talk about our models. So what is our favorite data model? Over the past few years, neural networks have turned out to be powerful models, providing excellent results. We use a transformer, which is a new family of NLP neural networks. I recommend reading the article "Attention is all you need" to better understand the concept behind the transformers. When training a model, we need to choose which model to use, which transformer, and also tune many parameters as optimization technique, learning rate, etc. This is not a trivial task. To do so, we use Hugging Face library, which made it easy for us to experiment with many types of transformers and their parameters. To date, as you know, NLP models includes many Muppets as Elmo, Bert, Roberta, etc. With enough examples and the right model, we can initialize our embedding layer to random values and let the network turn them into good vectors. When we move to transformers, we managed dramatically to improve our model accuracy. But the question still was, how could we improve it further? We discovered that by translating our sentences, we could further improve our accuracy. Translating our sentences from English to other languages and then back to English improved our F1 scores in about 5%. Take a look on the example in the slide. They look so dumb. We translated it to French and then back to English, and we got they look so stupid. Translating all the training set from English to several languages and then back to English resulted in increasing our training set, and we have gained diversity in the sentences. This resulted in more accuracy to our model. In addition to accuracy, there are more factors that need to be taken into consideration, like runtime and scale in production. BERT runtime was not practical in our case, so we had to speed it up. First, we reduced the sequence length, the input size. This reduced our runtime by about 30%. Then, we used smaller models, such as Zilberbrand. This further reduced our runtime by 40%. There are more factors like the hardware that we are using. We use GPU or CPU, depends on the application. For real-time applications, we use CPU. For batch application, we use GPU. We got amazing results. Our personal insult model has practical runtime of 100 milliseconds, and look on the slide on its amazing R curve. And finally, to summarize, we at Light deliver high-quality detections with practical runtime using the wash, rinse, repeat data science method to build and improve our transformers models. Thank you for your attention. Thank you for inviting me. Please feel free to email me any questions or comments. Thank you.